Okay, part A, we're looking for the area of the region R. So, what's the setup? The integral
from 0 to where they intersect.
Okay, so, but give me the integrand first. It's going to be
f of x minus
f of x minus
g.
g of x. And then dx, right? You guys okay with that? We need where they intersect, so we're going to graph it. We're going to set them equal to 0, or set them equal to each other, or find the intersections on our graph. So what do we get there?
1.1569.
Intersection. And 0?
Yeah.
When x equals 0 and what?
1.13569.
And you want to use all the numbers you can to be more accurate, right? So it's the integral from 0 to 1.13569 of, and this is the best way to do it, but you can only do this if they have clearly identified that this function is f and this function is g, right? If they just say this equation and they don't label it as f, they say y equals, you can't say y minus y because they're both going to be y's. So you can write it like this unless it doesn't say. If it doesn't say, you've got to actually write it all out. 1 plus sine of 2x minus e to the x over 2. What did you guys get there?
0.429.
Is that okay? Who didn't get that? You did get that? What did you get? Did you set it up like this? With the correct units? Points of intersection, probably wrong. Okay, notice how they did their notation. See that? They put the upper bound as s. Why? You see up at the top there, they said the graph of f and g intersect at the first quadrant, right here. They labeled it. They said, let s be this. That way they didn't have to write it all out. You can do that if you want, yeah. So, but you'd have to say it. So I would say, if you're going to do that, I would say I'll use a. Let a equal 1.13569. Therefore, the integral from 0 to a of f of x minus g of x dx. And that's perfectly fine. As long as you state that. If you just say a, then no, they're not going to give it to you. Okay? So you would get 1 point for the integrand, so 1 point for this piece, and 1 point for the correct answer. And you get 1 point if you have the correct limits on A, B, or C. So since you already have it for A, hopefully, you're not going to get any more points for that one. Okay? Part B, is that going to be a washer, or is that going to be a disc? It's going to be a washer. And maybe I can help you see it a little bit here. We are looking for the volume as I rotate this object about the x-axis. So, what is, let's see if I can do this here. What is the big radius? The big radius is this guy, right? Because we're revolving it about the x-axis, right? So big R equals f of x. And then little r is what? So what's my equation then? Pi times the integral from 0 to, I'm going to say a because I already identified a as that. Of what? F of x squared minus g of x squared dx. Again, it's not f of x minus g of x squared. Right? Okay. If you need to, think of the volume of the whole thing. So we could say we have this object. Let's rotate that object down here and find this volume. And then find the volume of this guy. And then do what with them? Subtract them. This is the whole that's being removed from that. Right? Okay? So you could separate it into two separate integrals if you need to. What did you get for an answer? 4.267. Okay. And notice there's no units on this, so let's see how. Okay. Oh, that's because it's. Okay. So you get, this is weird how they state this, and I don't agree with it. It's always precarious. You get 2 points for the correct integrand. So if you said f of x squared minus g of x squared, or if you said y plus sine of 2x and then all squared minus e to the x over 2 and then all squared. 2 points for the correct integrand. And notice it says minus 1 for each error. What kind of errors do you think that they would look at?
If you put f of x minus g of x squared.
Yeah, so they probably say f of x minus g of x squared is an error. Okay, as the integrand. If you just said f of x minus g of x like this, that would probably count as an error, as long as you have the pi up front. But what does it say? It says 0 out of 2 if integral is not of form. That doesn't make any sense. That's what I'm saying. This doesn't make sense. What's this constant mean? It's the pi, right? Is it wrong if you have the pi inside? So if you said the integral from 0 to a of pi times f of x squared minus pi times g of x squared. Is that wrong? No, it's not wrong. It's perfectly right. It's going to give you the right answer. So for them to say it has to be the constant out front as an issue, it has to be like that, that's not true. They would accept this as well.
Do we have to write it like that? That can we put like the actual function for f of x?
You can, just as long as you got parentheses around the thing that you're squaring, right? So they can, that's probably where they mean by error. So if you said the integral of, what was the first function? If you said 1 plus sine of 2x and then squared like that, minus e to the x over 2 and then squared, something like this, that's an error because what are you squaring? Yeah, well, in this case, yeah, it depends how you write it. So you got to have parentheses around it. All right, so that's that. And then the last one is the one I want to focus on because that's the one you guys are having a hard time with, right? What does it say? It says the cross sections are perpendicular to which axis? The x-axis. So we're going to draw a little line, and it even says the distance from F to G is the what?
The radius.
No. What does it say in the problem?
Base of the base.
It said that F and G, the distance is the diameter, right? So what would express, give me an equation that would express the diameter. Diameter equals f of x minus g of x, right? What would the radius of these semicircles be then? It'd be 1/2 of f of x minus g of x. You guys okay with that? Now what's the form for all volume problems?
Pi
No. In any volume. It's the integral of the area. What are we doing in respect to x or y? X. So the big question is, what is the area formula? Well, we know the limits. The limits are 0 to a again, right? What's the area of these objects? What are they? So area equals 1/2 pi r squared. Agreed? But we know what r is. So area equals 1/2 of pi times 1/2 of f of x minus g of x squared. You guys okay with that? This is your radius squared 1/2 pi. You okay with that? So now this is going to be the integral from 0 to a. And since 1/2 pi is a constant, I can take it out. Can I take out this 1/2? No, because I'm squaring it, right? So I'm just going to leave it in there. It's going to be 1/2 of pi times 1/2 of f of x minus g of x, and then all of that squared dx. Anybody get an answer for that one? 0.078. What do we think? Oh. Nope. Yes. Wait. Where is it? There it is. 0.078. So 2 point for the correct integrand. Notice how messy that is. All right. They just put the 1/2 on the bottom on that. Is there any questions on this one? That's usually how these FRQs work. Part A is find the area. Part B is find after you revolve around something. And then part C is some cross-sectional thing. Okay? Okay, so go ahead and work on the backside then.